Me and our team members are welcoming you to the project by 360DigiTMG. This presentation is about appointment scheduling for sample collection. We came up with a machine learning algorithm which gives proper schedule to the agent for collecting home samples with minimum loss and reaching on time to the diagnostic center. This ML algorithm helps to increase the overall growth of diagnostic center. Before I proceed further, we would like to thank and happy to announce we have completed this project under guidance of Mr. Bharani Kumar, Director of 360DigiTMG, and Mr. Sarath Manikonda, Director of Innodata Tech, and our project mentors, Ms. Divya Janani and Mr. Madan Kumar. Next slide. These are the team members who are working in this project: Sai Kiran, Arika, Aditi, Bhavesh, Bindushree, Vinodini, and myself, Nisha. Next slide. We have used ScriptML methodology to create this project, which is listed ahead. These listed topics will be explained by respective team members. Now let's see contents of this project. Introduction, project overview, project goals, business pipeline, technical stack, project architecture, data collection, followed by data preprocessing and explanatory data analysis, and data visualization using Tableau, model building, model deployment, and working of deployed model, and output of our web page, future scope, and finally conclusion. Next slide, please. Yeah. Now I would like to take you to the basic introduction of our project. Our project main aims to streamline and gives a proper schedule for sample collection, plan schedules, assign tasks to specific field agents based on number of parameters configured through pathology lab business rules. We provide route optimization. It helps agents who is collecting samples from customer's place to find the best way to get from source to destination. That means customer place to pathology lab under unforeseen conditions and real-time traffic. A summary of the timing of all the sample collections is provided in table format to the agent who is going to collect samples in the given date. Diagnostics at doorstep, which are hospital standard reporting, expert technicians, and high precision equipment. From our project, Diagnostic Center gives dependable and convenient service, rest assured with all the required tools to do the needful. Here we used unsupervised k-mean clustering algorithm, which helps to group a set of locations of patients based on various parameters such as distance, availability, orders, etc. Next slide. So, sample loss is the big concern in medical field. So how to overcome wastage of some medical sample? How can our model help this? The fundamental idea is to identify the formation of clusters, that is groups, for given medical sample collection data of particular date. Machine learning can be used to know the patterns in given data and cluster them accordingly. The complete project comes with the idea to help diagnostic center to sample collection schedule of patients, generating clusters by agent ID, and assigning to an agent for at home sample collection for a given date. Dynamic and automated scheduling facilities, intelligent scheduling, work order allocation, and planning to reduce agent downtime and cost significantly. It also allows a combination of batch and real-time scheduling. Next slide. Next is the goal of our project. Our main objective is to build a web application for predicting the schedule of a particular agent on a given date, and make sure to use terms like minimize and to increase the overall growth of diagnostic center. It is our main aim, project aim and constraints. During our project, we found there are a few constraints out there. That is, the model may get impacted by unforeseen conditions like weather conditions and the customer's absence and agents' unavailability. Yeah, that's it. From next slides will be taken over by my teammate Vinodini. Thank you.
Good evening, everyone. This is Vinodini. I'm going to explain from business pipeline slide. This slide talks about CRISP ML methodology. CRISP ML is a systematic process model for machine learning software development that creates the awareness of the possible risk and diminish the risk to ensure that the machine learning project is success. In CRISP ML, we have 6 phases. The first phase is business and data understanding. The goal of this phase is to ensure the feasibility of the project. As data guides the process, data collection and data quality verification are essential for achieving the business goal. The second phase of the CRISP ML is data engineering. This phase aims to prepare data to build a better model. During this phase, we perform tasks like data selection, data cleaning, feature engineering, and data standardization. Here we select the data by discarding the unwanted data which do not satisfy the data quality requirements. Data cleaning tasks perform error detection and error correction for the available data. And at last, we standardize the data to avoid the risk of the erroneous data. Finally, we build the data and input it for data preprocessing. The third phase of the CRISP ML is model building. This phase includes model selection, model specialization, and model training tasks. Here, we might use pre-trained model or compressed model to finally build a better model with better accuracy. The fourth phase of the CRISP ML is model testing and evaluation. Once the model is built, we have to test and evaluate the model and get the appropriate accuracy. Once all these are done, we will move to the deployment part, where we integrate our model into the existing software system. The sixth phase of the CRISP ML is monitoring and maintenance. Once the machine learning model is put into production, it is essential to monitor its performance and maintain it. Next slide, please. Yeah, this slide talks about the technical stacks that we used. MySQL is used to import and export the SQL files into database. Python is used for data collection, data preprocessing, and model building. Spider and Jupyter are the integrated development environments. It is an essential building block, includes advanced editing, code analytical tools, Python console, variable explorer, etc. And Tabule is used for data visualization. And we used Flask for the web development using HTML and CSS. At last, we deployed our web in the Heroku and GitHub. Next slide, please. Yeah, this slide talks about the project architecture. Here, first, we need to understand the business problems, its objectives and constraints, and what type of data has to be created for this business problem. Once we understand that, we extract data from the online sources and store it in the database management using IDE Python connection. Once the data is stored in the MySQL database, we perform data preprocessing and exploratory data analysis. In this process, we eliminate the inconsistent data and remove the duplicate data. Once this process is done, we perform data visualization and we build a model. Here, we used K-means clustering to build a model. Here we have done the clustering according to the agent's availability. Once the model is built, the next part is a deployment using Heroku. And after the deployment, it is essential to monitor and maintain it. Next slide. This slide also talks about the project architecture. Here we drop unwanted data columns, filtering data according to the given data, taking the availability of the agents. Here clustering is done according to the agent's availability, taking the agent's ID, filtering data according to the given agent's ID, sorting the data according to the availability time of the patient, showcasing required column for agent. Henceforth will be explained by my teammate Bhavesh. Thank you.
Thanks, Vinodini. So data collection or data preparation, it is a process that largely consists of data acquisition and data labeling. This slide depicts about data collection that focuses on collecting quality data from different sources. Data collection is a fundamental criteria for data science project and to analyze its business objectives. But before we collect the data, we should understand that what is the type of data we need. As we know, our model is working on collection of sample from patient and delivering it to diagnostic center. For that, we study the delivery system of e-commerce delivery guys and courier guys. how they deliver a particular parcel to customer and pick up the parcel from their place. We schedule what schedule they came with so they can deliver all parcel to their respective place in lesser time. After studying this, we came with the features which will be helpful in our model. Next slide, please. As a medical data we need is a sensitive, so this project data is a simulated one. No primary or secondary source were used for data collection. Certain inputs were collected from diagnostic center and some are randomly generated. Finalized collected data was framed in Excel and imported to SQL. We have created 26 features for which we have 1336 data points, out of which some important feature we have mentioned here. First is patient ID. Since patient names can be same, we have assigned every patient with a random patient ID, which will be very useful in tracking patient data. Second is agent ID. Every agent will have a different ID, which will be helpful in assigning agent with schedule to agent. Third is PIN code. PIN code is the area of patient living in. Fourth is patient location, area of the patient. Fifth is diagnostic center. Name of the diagnostic center patient opted to submit their sample. Sixth is availability time. At what time patient is available to their home or house. So the sample collection process can be done in minimum time. Seventh is shortest distance from path lab to patient. This feature will be helpful in assigning route to agent so sample collection can be done in less time. Eighth is test name. Which test patient booked for? Ninth is sample. What type of sample to be collected from patient? 10th is a way of storage of sample. In what type of container or vacuum tube sample to be collected. 11th is sample collection date. The date on which the patient asked the sample to be collected. Next slide, please. Exploratory data analysis, also called as descriptive statistics. Exploratory data analytics is as an approach of analyzing data that to summarize their main characteristics, often using statistical graphics or other data visualization methods. We can see that how we take raw data and after doing some analysis steps, we reach to a certain conclusion. The data steps are first moment business decision as measure of central tendency, which will be helpful in getting mean, median, and mode from the dataset. Second moment business decision as measure of dispersion, in which we used to get variation, standard deviation, and range from the dataset. Third moment business decision is skewness, which shows us the data distribution. Fourth moment business decision, kurtosis, to analyze the peak in the frequency distribution curve. Fifth is graphical representation, in which we draw univariate graphs like bar plot, histogram, index plot, etc. Other is bivariate graph like scatter plot and multivariate graph like pair plot to analyze these data. Next, please. So we have drawn some statistics from our dataset, in which number of feature or variable we have are 26, number of observation we recorded are 1336. There is no null value in our dataset, nor we have any duplicate values. The total size memory of our dataset is 115 KB. The data type of variable we have in our dataset are, we have 17 features with categorical data type, 8 features with numerical data type, and 1 feature with date data type. Next slide, please. We have also performed EDA to discover trends, patterns, or to check assumption with the help of statistical summary and graphical representation. As we see in first graph, the most number of sample order we are getting from age group of people 20 to 80. In a second graph, we can observe that most type of sample collected is a blood. So here we can conclude that agent must have to keep enough blood storage tubes. Here in third graph, we can see most number of a test agent collecting sample is for urine analysis. Fourth graph shows us that 98% of the people ordering for sample collection are living under 25-kilometer distance from diagnostic center. Next step is data processing, which will be explained by my other project mate, Aditi. Thank you.
Thank you, Bhavesh. And I am Aditi. So before going to data pre-processing, first we have to know what is data pre-processing and its importance. Data pre-processing is a process of transforming data into useful, understandable format. Real world or raw data, usually inconsistent formatting, human error, and also incomplete data are found. So how we can resolve? So here data pre-processing resolves such issue and make data set more complete and efficient for data analysis. It is a crucial process for model training and its accuracy. And 80% of data scientists' time is spent on data preparation tasks. Now, come to this slide. This slide focuses on data pre-processing and technique applied. Our data is structured format. This is mainly a focus phase where we prioritize features, drop unnecessary column which does not deposit more inference. So we can see one by one. First is missing data handling. In our data, no missing value is found. Otherwise, if there is any missing value, we have to perform mean, median, mode imputation. And the second is duplication data. There was no duplication data observed. Third, we have taken relevant data only, which are considered for model building. Fourth, we have done label encoding to our categorical column, which convert to numeric so our machine can understand the data. We have done, in fifth point, we have done standardization because our data set have different unit of measurement. So to rescale the attribute mean as 0 and standard deviation as 1, we are using min-max scaler. And we are not performing any outlier treatment because every data is unique. So we have retained it. Next slide. So as I mentioned in before slide, we are doing label encoding. So this is a picture of before and after application of label encoding, which convert categorical to numerical form. Next slide. So this slide here, we standardize as particular column for clustering because k-mean using distance algorithm like Euclidean distance, which is mostly affected by range feature. This is because behind the scene, they are using distance between the data points to determine their similarity. So as we see above, we are taking 4 column for clustering using min-max scaler. Next slide. So come to the data visualization part. As we know, data is a new oil in 21st century, or as a human being, it is very difficult to analyze the raw data as it is. So we are trying to understand the data in a better way. There is a data this is where data visualization play a major role. Through visualization, we can absorb the large amount of information from the data quickly. It helps us to provide useful insight to take some important business decision. And it also useful for data cleaning, detecting outliers, identifying trends, clustering, and etc. For visualization, we are using Seaborn and Tableau. Next graph, please. So yeah, we are using Seaborn and Tableau for visualization part. This first graph show patient location and we get inference. Most number of patients are from Madinaguda and Dr. A.S. Ravnagar. And this the second graph shows the time visualization in the maximum specimen collected by this time range. Next graph. Yeah, and we are also making Tableau dashboard for all to get more insight. And this is a line graph. We are seeing it show the trend after the month of May because COVID cases decreasing. So demand of home sampling is also decreasing. And the second graph is show way of storage of sample, which show vacuum blood collection tube is mostly used because most of the disease detected by blood test. And the third graph is diagnostic location in which patient mostly prefer to book Lucid Medical Diagnostic Center. Thank you. And next slide will handle by Arika.
Thank you, Aditi. Good evening, everyone. Myself, Arika. I'll be explaining model building. In model building, this is the phase where data science team needs to develop data sets for training, testing, and production purposes. These data sets enable data scientists to develop analytical method useful for predictions. In order to build a model, first criteria is to understand the problem on which objective we have to build a model. Secondly, we need to collect and process the data and select variables. Next comes a crucial part where data scientist uses his skills to choose appropriate model to build. Later, we train the model where machine learning learns patterns, following which we evaluate using validation techniques that gives a successful model. Then comes the most awaiting phase, that is prediction. As our objective is based on scheduling, we chose unsupervised learning where no output variable is defined, for which we use clustering algorithm for analysis. Cluster analysis has been widely used in the field of biology and medical science. Among all unsupervised models, we used k-means clustering as it is widely suitable for our objective. What is k-means? K-means clustering is a very famous and powerful unsupervised ML algorithm that is used to solve many complex unlabeled data problems. K-means groups the unlabeled data set into different clusters where the value of k has to be predetermined using elbow curve. Now, elbow curve method. Elbow curve is used to select optimal numbers of clusters to perform k-means clustering by plotting a graph, where elbow method is more of a decision rule. Next, silhouette analysis. The other metric is silhouette score that shows how similar a data point is within cluster compared to other clusters. Silhouette is a metric used for validation while clustering. And it is a centroid-based algorithm where each cluster is associated with a centroid, which is the center point of the clustered or grouped data. This slide focuses on libraries and packages used for our model building. We used Pandas library for data manipulation and analysis. Next, to perform mathematical and scientific computing, we used NumPy tool. Next, Matplotlib is used for data visualization. And MySQL connector is used to access MySQL database. Next, from sklearn, we imported label encoder function to transform non-numerical data to numerical data and min-max scaler to rescale variables within the range of 0 to 1. Our objective-based k-means is also imported from sklearn to perform clustering and create number of clusters. Next, this slide shows you columns we used for clustering. There are 4 columns we considered for clustering, which are based on distance and time according to our objective. First is shortest distance from pathology lab to patient. After specimen collection of patient, this helps agent to deliver specimen back to diagnostic center within a stipulated time. Second, availability time. This is where agent reaches the patient to collect sample considering his or her availability time. Third, patient location. We considered patient location in clustering, which is necessary to target clustering based on similar locations. Fourth, diagnostic center location. This is used as it would be easy while clustering similar points with respect to same diagnostic center. Below image depicts you how the clusters are formed, taking above 4 columns. Model explanation. This slide explains about technique applied for model building and prediction. Firstly, we dropped irrelevant or unnecessary columns which are not useful for our objective. Next, we label encoded the categorical columns to convert them into a numeric form so as to convert them into the machine readable form. Third is standardized data using min-max scaler to obtain scaled data points for particular 4 column values as mentioned above. Then Random points are selected based on agents availability and shortest distance is calculated. And after each iteration, we get clusters. Then this process continues until proper clusters were formed. Fifth, once proper clusters are formed, it stops the process and generates labels to each data point for a particular selected date. Then the model is ready. This image shows you how clusters are formed selecting particular date along with required columns for agent to reach and collect sample, which we filter according to agent ID, and generated report is given to respective agents based on their ID numbers. And those columns will give you the complete information of the patient ID and patient location, where to reach the patient, longitudes and latitudes coordinates are used, where the route can be mapped. And henceforth will be explained by Sai Kiran. Thank you.
Yeah. I am Sai Kiran. I am taking the part of deployment. Here, before talking about deployment, we should have a minimum idea how to construct an application. Here we are using the framework, Flask framework, which is used to construct a server application. Here, the HTML pages are get activated by using the server. How the server works? The server works according to the HTTP requests. We are using only two requests. One is get request and the other is post request. Same as we discussed before, get itself says that it receives the data from the particular websites. Means whatever HTML files we are approaching, it will collect the information from the HTML the app application, and post request makes that it generates some output, and it will be posted in the HTML page. The main thing I want to say that get and post requests are plays a crucial role in the server. Once the application is running perfectly in the local system, we go to deployment. The deployment we usually followed Heroku deployment. In Heroku deployment, the requirements are requirements text, which includes all the packages involved with its versions, and the proc file itself says which app should run first, and after creating these two files, we commit other files also. We keep other files like app.py and HTML files, which we work on in the same folder, and using the GitHub, we can upload using the GitHub, we can GitHub repository, we can upload the deployment. If deployment is not working with respect to GitHub repo, we can manually do it using CLI, command line interface. In command line interface, we should go to that folder and click CMD in the address, so that the terminal will be opened according to that address. On addressing that address, we commit some Heroku commands, which will be shown in the CLI Heroku commands, and we follow those commands, and we will deploy the whatever app or application we deployed. In this way, the deployment task will be completed, and it generates a link as mentioned below, and this link will be universally usable for anyone who click on it. And next slide, please. This is the application. I used. Here scheduling date will be taken, agents availability will be taken, and according to the agents availability, these many clusters will be formed. If we take agents availability 3 clusters will be formed after clicking on starting cluster. Next slide, please. Once the clusters are formed, it turns to the next HTML page, that is this. In this HTML page, we will take a agent ID. The agent ID should be less than number of clusters. If there are 3 clusters, the agent ID can be 0, 1 or 2. Once we take the agent ID and click on show schedule, the schedule will be generated as below according to the timestamps, according to the availability time of the patient from morning to evening. The whole schedule will be shown to the agent, and this way all the requirements of the agents will be fulfilled by this schedule. And through this scheduling, we solve the problem of appointment of the scheduling of the agents will be solved. The problem of the agents will be solved. And thank you. The next slide will be presented. Thank you.
Hi everyone, I am Bindushri. Today I am going to speak about the future scope of our project. Here we have used K-means clustering to build our model. This model can be further extended based on the requirement of the diagnostic centers. We can add more features, characteristics. We can add also the GPS tracking of the agents. So it will be very easy for the patients to know at what time the agents will be reaching their location. So they can be available at that time, and the agent can quickly collect the sample and transport it back to the diagnostic centers. This automating sample collection can also be further implemented in all the diagnostic labs. Here we have taken only few diagnostic lab as part of our data, but it can be used in all the other diagnostic labs around the state and around our country, which will be very useful for the patients as well, and as well as more profits for the diagnostic labs as well. Next slide, please. So we are almost reached the end of our PPT presentation. So coming to the conclusion part, I would like to say that ML here, machine learning actually solves quite a lot of real world problems in today's life. So here we are trying to take one of such real world problems and try to build a model so that it solves the problem. Here we are using K-means clustering, which is one of the very good clustering models, we can say, and we are getting an optimum solution for our real world problem as well. This automated solution can be implemented in the diagnostic centers, which is very helpful, and the patients need not go to the diagnostic center to provide their samples or to collect their reports each and every time. So this is a very user-friendly kind of automated solution where the patients or the users can actually sit back at home and get everything on the go. And this is also helpful for the diagnostic centers. It is also profitable, you can say, for the diagnostic centers to assign the agents with their schedules and also to track them on collecting the samples at a particular time when the patient is actually available at their premises. This is and this also can be further expanded and based on the functionality of the diagnostic centers. So I would like to thank all my teammates for contributing and helping and completing this project successfully. I would like to thank Barney sir as well, the director of 360DigiTMG, for giving us the opportunity to work on this project, and also Sharad sir for mentoring us throughout the project, and also our mentors who guided us through all the small queries and solved all our problems. Thank you all.